In this video, we're going to go over the 2008 AP Calculus AB Form B FRQ number 2. And even before we get into this problem at all, just the key to this problem is units. Pay attention to what your input and your output represent. So they give us a couple different functions here. First of all, they give us r of t, which represents the speed, not the velocity, in kilometers per hour at which a car travels along a straight road. And then the number of liters of gasoline used by the car to travel x kilometers is modeled by this function. Right away, I'm noticing that the input of this function is t hours, and the input of this one is x kilometers. So different inputs, which is strange already. All right, now what are they actually asking me? How many kilometers does the car travel during the first 2 hours? Well, that's a distance traveled, not a displacement question. So usually I have to be careful with that, but they actually gave me speed, not velocity, so I'm all good. The distance traveled is the integral of the speed function. So it's just the integral from 0 to 2 of r of t dt, which is going to be, let me find where I have that, 206.37 kilometers. It didn't say I have to write the units, and so often I say don't write the units in case you make a mistake. You don't want to lose a point. But like I said, to start this problem, the units are just super important, so I'm writing it really for my benefit here. Part B, find the rate of change with respect to time of the number of liters of gasoline used by the car when t equals 2 hours. Indicate units of measure. Well, the rate of change of gas makes me think I want G prime. But G prime of x is really dg dx. And that's not what I want. I want dg dt. That's what we want, the rate of change with respect to time, so it's got to be dt, of the number of liters of gas. So if we just think about the fractions here, dg dt should be equal to dg dx times dx dt, because that will cancel out the dx's and leave me with the two pieces that I do want. Now, as we just said, dg dx, well, that's just g prime, so that's not too difficult. But dx dt, I need to figure that out, but x is kilometers and t is time, so dx dt is really r of t, the rate of change of kilometers over time. Hey, that's what this is. So that's, oops, sorry, my r looks sort of ridiculous there. Make that a little better. And my units are important, so I do want to make sure that that's clear, that that is clearly an r there. Okay, so the question is, okay, find this thing when t is equal to 2. So that's no problem because I can find r of 2. Just plug that in on my calculator. But then I can't plug in 2 for this x. Again, units super important because this is a t, time, and that's an x, kilometers. But fortunately, I know how many kilometers we go in the first 2 hours. I go this many. So this is g prime of 206.37. And that's again because the question is wanting to know what is this rate of change when time is equal to 2. But when time is equal to 2, x is equal to 206.37. And then I just need to multiply all that out, and I get 6 liters per hour. So I'll say it one more time. The units are super important here. You've got to go careful. You've got to be careful, go slow, and recognize, okay, what units are they asking me about? What units do I have? How can I connect these things? All right, if you need to pause, work through that for a minute, please do that. I'm going to get rid of all this work here. All right, so once again, I've got units to worry about. How many liters of gasoline have been used by the car when it reaches a speed of 80 kilometers per hour? Well, they're asking me about the number of liters of gas, so that's good because I have a function for that. But the input of that is supposed to be how many kilometers I've gone up to that point, not how fast I'm going. So I have to figure out how many kilometers I've gone by the time I reach 80 kilometers per hour. Okay, 80 kilometers per hour, that's a speed, as it says. I have a function for speed. So I need to know, when does r of t equal 80? And I'm just going to solve that on my calculator. And I'll get a time of about 0.3315. So after that much time, we reach 80 kilometers per hour. So again, the question is asking how many liters of gas have been used. I have a function that tells me how many liters of gas have been used, but my input is supposed to be kilometers driven. Well, I went from speed, kilometers per hour, to time, but I need to know kilometers driven. But if we look back at part A, I was able to go from a time to the number of kilometers driven by using the integral of r. And so that's what we'll do again here. So now I need to say, okay, the integral from 0 to 0.3315 of r of t, the definite integral of my speed, should give me my distance traveled. That's going to give me about 10.794 kilometers. And now I can finally plug that into my G, because G has an output of the number of liters of gas used and an input of kilometers driven. So now I can say G of 10.794. Just plug it in on my calculator, and I'll get 0.537 liters of gas. Definitely a tricky one. You've got to really slowly think through the units. Sometimes people will get to this one and they think it's pretty straightforward. But if you stop and think about the units, it's a little more involved than that. All right.